Hey everyone. All right, this video begins a new unit for us, polynomial functions. This one in 30-2 is not a long unit, and if you're going in the order that I'm doing these videos in, it's not near as hard as rationals. So yeah, it'll be a little bit of maybe a breath of fresh air. This first lesson here is just a review of some of the things we already know about polynomial functions. This is not long, and probably if your teacher is doing it like this, they're probably going to combine lesson 1 and lesson 2 together in one day. I'll have them as two separate videos just for the sake of keeping everything succinct. But yeah, this one's not. This is just talking for a couple minutes, making sure we're all on the same page before we dive into what we need to do for 30-2 polynomials. Okay, so here is some stuff to chat through with you. I'm just going to hide my head for a quick second. Remember, recall. Actually, I want to see your face when I talk about this. Recall. When we see that in a note, it sort of means, hey, you're supposed to know this already. Okay. I don't ever want that statement to stress you out, right? If you don't know it already, that is totally okay. Maybe you weren't there that day, or maybe you fell asleep that day. I don't know. But when you see that word recall, just remember that it means we really want you to have a good understanding of what we're saying right now. So if you're a little bit maybe unsure of some of the things that are being said, there are tons of videos in grade 10 and 11 that you could go back, look up, and just kind of get it all fresh in your head again. Okay, so don't stress. Okay, I'm going to hide again. A function is a special type of relation such that for every input, there's only one output. Now, what are we looking for in those brackets? Just a reminder that the input would be your x value and your output would be your y value. Okay, so a function is a special type of relation that for every input, there's a single output. Now, what that means is x can't be duplicated, right? So if I just want to turn my ink on here for a quick sec. If I had given you something like a table of values that might look like this, and I had 2, 2, 3, 1, 4, 10. Okay, 2 comma 1 and 2 comma 4. That means for the input of 2, there are two different outputs, 1 and 4. Okay, and in grade 10, we talked about the fact that visually, what happens there is it wouldn't pass the vertical line test, right? So if I took a look at maybe right here, let's just say that was at x equals 3. 3 comma something would be up there, and 3 comma something would be down there. So x is getting duplicated. So those are not functions, okay? So a function won't have any duplicate x. Function notation, now this was also a specific note in grade 10, okay? Function notation is a notation used to describe a function. It simply replaces y with f of x. Remember that f is the name of the function, and f of x means the function evaluated at x, not f multiplied by x. So if I had given you maybe f of x equals 5x squared minus 9, and I said, oh, we're going to look at f of 1. That doesn't say the letter f times the number 1. It says put 1 in for x into my function. Okay, so it says evaluate the function when x equals 1. So it would look like this, and I would plug in 1, and then I would do the math from there. Okay. All right, so for example, since y equals 2x plus 3 is a linear function, that would be a line, right? Just for quick review, I would have a y-intercept at 3, and I'd have a slope of up 2 over 1, so it would look something like that, right? We can also write it in function notation then, and all we do is we split, or we substitute, sorry, y with f of x. So that would be f of x equals 2x plus 3. Okay? Easy. All right. The Cartesian plane. Some vocabulary. Again, hopefully you're comfortable with most of what you see here. I'm going to hide for 1 sec again. The Cartesian plane is a grid with 4 sections called quadrants, okay? Now, just for clarification, I know I'm still hiding from you. but we would go quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We often label them in Roman numerals, okay? Formed by the intersection of two axes, the horizontal x-axis, which would be this guy here, and the vertical y-axis, which would be that guy there. Each point on a Cartesian plane, I think I can come back now. I don't like not seeing you. Each point on a Cartesian plane can be represented by an ordered pair, and it would be in the form x comma y, okay? X comma y. All right. The domain essentially means everything that x can be. So the domain is the set of the first elements in a relation, i.e. all the values that x can be, and then the range would be everything that y can be. So the range is the set of the second elements in a relation, each associated with a particular element in the first. So each item in the range is connected to an item in the domain, is what we're saying there. Yeah, so all the values that y can be. Okay. All right. The x-intercept, I'll hide for just a quick sec here. The x-intercept is the point on the graph that crosses over the x-axis. And we write it in, so anytime you are asked for an intercept, it must be a coordinate point, okay? So it's written in the form x comma 0, because the value of y is always 0 if I'm on the x-axis. If I'm on the x-axis, I haven't gone up or down. Okay, so it'd be whatever the value of x is, comma 0. The value of y would be 0. Now, the reverse statement of that is the y-intercept. The y-intercept is the point on the graph that crosses over the y-axis, and then its point still has to be coordinate, right? But it would be 0 comma whatever the y value is, because it always goes x first, then y first. This is a great time just to have a little gentle encouragement on how I write a point. When I mark kids, I see a lot of kids going like this and calling that a point. Okay, they're saying, oh, that's the point 2 comma 3. It's actually not the point 2 comma 3. We could say mathematically you've drawn maybe a sequence that goes from 2 to 3, but until you have brackets around it, it is not a coordinate point, okay? And the brackets mean something. They have to be curved brackets here. Don't draw square brackets. Don't draw squiggly brackets. They all mean something different in math, okay? So the point has to be open bracket, your x value, a comma, your y value, and then a closed bracket. That defines a coordinate point, okay? So just be careful in your communication, I guess, is all I want to encourage you with there. Okay. Hide. A polynomial function is a function that has exponents on variables that are whole numbers, okay? You don't want a negative exponent and you don't want a fractional exponent. We have already studied linear and quadratic functions, and then today, which is actually going to be the start of our lesson 2, so that'll be on a different video for me and you. Today we'll begin cubic functions, okay, which is a degree 3. Sorry, I can't seem to come back to you. There I am. Okay, I was clicking to come back, and I couldn't figure out why. Okay, never mind. It's all good. A blank function can be of the form y equals a to ax plus b, so that would be a linear function. And then a quadratic function can be in the form y equals ax squared plus bx plus c. Now you spent probably a good solid month in grade 10 dealing with linear functions. And then you probably spent a good solid month in grade 11 dealing with quadratic functions, okay? So those guys are probably decently familiar to you. Okay, but they're both polynomials, okay? Okay, constant term, hide. A constant term is a number that always has the same value. So this means there is no variable attached to it, okay? Numerical coefficients, those are the numbers in front of the variable, okay? So if I said, let me just get my ink here, 3x squared minus 7x plus 5, okay? And I said, hey, what is the coefficient on x squared? The coefficient on x squared is 3. If I said, hey, what's the coefficient on x? be careful with that guy. You would want to answer the coefficient on x is -7 because you always have to take into account the sign that's in front of that number. Okay. And then we might as well finish this statement. What would I ask for the last one? I would say, hey, what's the constant term? The constant term is 5 because there's no variable attached there. Okay. Then the leading coefficient of a polynomial is the coefficient of the highest power of the variable. So in this example, the leading coefficient would be 3 here. Okay. This is just an expression right now. If I want this to be a function, let's actually just call this f of x equals so that it's a function. Okay. Okay. Awesome. That's all I want to talk about in this first lesson. Just a quick review of some vocabulary, just making sure everybody's comfortable. And then in lesson 2, which again, most of your teachers probably are going to combine these two things together. But in lesson 2, we're going to dive into some characteristics of polynomial functions, and we're going to introduce the cubic function. Okay. But for now, I'm going to leave you be until you go find the next video. And so this is what we've covered in your book, and you, I hope, have a lovely day. Thanks for watching. Thanks for sharing these videos. I do really appreciate you getting the word out for me. And as always, thanks for subscribing to my YouTube channel. I appreciate it. Take care, guys.